Okay, so this is one thing what we have actually we have done here. Okay, and this similar kind of thing, it's not new. You have already seen that. Okay, now let us go to the next function, which is init function here. So this one is not new. You already know. So I'm not adding any comments. This underscore underscore init is basically a default constructor. Okay, so we have seen this in sequence to sequence model, Bahdanow's attention. I'm not going to add anything. Okay, I'm just going to tell what it is and just going to move forward. So vocabulary size, you are not new. So this is the total number of the words which you can use in the vocabulary. And then the embeddings, basically the dimensions of the word embeddings is what the embedding underscore dimension is. So then we have the encoder units. So encoder units are number of units inside the GRU, or you can say the GRU model, what you are applying here. After that, the fourth one is the batch size. So batch size is also is the number of size which is used for training. Okay, so all these things are not new. And then we are using the super function to use this default constructor. So this also is not new. Okay, so that is why I'm not even considering that also, because you also know all those things. After that, we are defining variables which are equal to the self, or which we can say they are able to define using the self which we have defined in a default constructor. So batch size, encoding units. Okay, so this is again not new. Already you have seen. So I'm not defining anything or writing any comments for that. So after that, the next thing is applying the next thing is before GRU, applying the embeddings model. Okay, so even this word, this also you're not uh, not new for that. So it is converting into word embeddings, right? This using this individual words and converting into vectors. Okay, so after that, applying the GRU model. Okay, so after that, applying the GRU model. Okay, now for the GRU model, this is very important. Just give me a minute. Yeah, so I will put in one line. Okay, so here we are trying to apply the GRU model. Okay, so we are taken the or we are taking the embeddings. This is also not a new step. Okay, so encoding units we are taking, and the return sequences we are taking, return state we are taking, and this also Glorat uniform. This is also we have seen already. I'm not going to touch upon something which you guys already know, because we have already seen that. Okay, so after that, we are going to define one particular function, which is the call function, the user defined function. Now, this also the same thing. This is basically the input values, right? The hidden gives the hidden states. Okay, and this X will pass with the initial embeddings of the function GRU, which you have taken here. Okay, so the output will be returning, we are returning the values output and state. So even this part is not new. Already I've seen in sequence to sequence model as well as the Bahdanow's. Okay, now even the next part is basically initializing the hidden state. Okay, so we know that we initialize only the previous state for the Luong attention. So we are only giving the previous hidden state. Okay, now our function changes here. Now we are defining the Luong attention. Now we are taking the Luong attention and we are importing or inheriting the importance from the Keras layer or TensorFlow, I can say. And to understand this, we are defining the scoring function, which is a dot function. I think this needs a bit of, I would say, okay. Now, I think this is also you already understood, but what I'll do is just one comment I will add here. Okay, just one comment I will add here. 。 Please wait for the attendance link. It will be posted. Okay, don't feel tensed. Your attendance link will be posted like Luong. Okay, just wait for a few minutes. Okay. Now, the first comment here, what we are doing is we are actually defining, or we are starting to define the Luong attention. So the first part of that is we have seen, no, there are three things. One is the scoring function. In the scoring function, we have seen three things particularly. One is the dot product, one is the general, and one the concat. Correct, no? So to apply those, we are applying the first thing, which is the scoring function. Okay, so this will initialize the scoring function. Okay, so this will initialize the scoring function. Now, after that, we have defined one particular, which is self. Okay, so for this will store all the values which are, which are actually created using all the three, which is the dot, general, and concat. Okay, now the next part is doing the general function. Okay, so this basically initialize the layers. Okay, so anyway, I'm just adding one simple comment for this. Okay, this basically initializes the layers. Okay, that's it only. We have already understood that now what is going to happen. So in a simple language, let us okay. Yeah. So let us understand that. Now, after that, the next part is the self-calling. Okay. So here we are self-calling. Okay. Here there are two things. One is the query, right? This query is basically the target hidden state. Okay. And the next thing is the values, which are the source hidden state. Okay. After that, the next thing is the calculating the score, okay, of the scoring function. Now it will start. Now the important thing starts here. Now the first thing is calculating the dot product. Okay. So the dot product is basically between the hidden state and the encoder. Okay. Wait, I'll put here. Okay, I'm putting here one line. So this dot product is basically between the decoder hidden state and the encoder's outputs. Okay, that is the first thing. Now to obtain the shape, okay, so here how the shape is obtained is, this is the formula. Okay, this is basically directly applied when you are applying this dot function. Okay, so here you are defining the self-scoring function now. So automatically that will be applied. So the shape will be on this batch size 1, which is the state, and the hidden size into batch size into SQL length into hidden size to the power t, which implies batch size 1 and SQL length. So this is what it is going to give you as an output. Okay, so that is what this dot product basically will give you. Okay, so after that, the next thing is the general one. So here we have, okay, so we have for the general one, we are having one particular here for general. Let me paste it here. Okay, yeah. Now to understand the general, what this general scoring function actually doing is, it is applying the linear transformations, okay, to the W, okay, to query before the dot product. Okay, so to understand what is linear transformation and what is dot product, basically I will suggest you to go through the concepts in linear algebra. You can see this concepts of dot product as well as the linear transformations. Okay, it's a pure math concept actually. Okay, so you can see both the linear transformations as well as the dot product. Okay, yeah. So coming to and this one is basically applied matrix multiplication. Okay, this multiplication is nothing but the matrix multiplication. Okay, and this is basically applied for the entire to calculate the score. So whenever you have taken the scoring function as general, automatically this formula is applied. You need not give this formula that is already embedded inside. Okay, if you want to understand how it works, you have to study a bit of math behind the application of this Luong's attention. Okay, because most of the generative AI and deep learning uses math. So coming to the next part of, or you can say the next particular function in the scoring function is the concat function. So now this concat function is basically using the nonlinearity. Okay. And here, let me post one comment here for concat. Okay. Yeah. So I can use this comment. Now, what this concat function basically is doing is it is concatenating the values between the query and the values. Okay, this is basically applying the dense layer. Okay, this is basically applying the dense layer as well as the non-linearity. Okay, and this will basically project the scalar score. Okay, now by using this particular formula again, here you can see the formula. Okay, I've mentioned here. So this formula is applied. Okay, you would say function or formula or anything. Okay, to calculate the score is basically applied to get the output for the concatenation function. Okay, so the resulting output will be the batch size 1 and the sequence length. This is what the output you will be getting if you are applying the concat function. Okay, so after that particular function is applied, the next important thing is applying the softmax. Okay, so the next thing is applying the softmax function. Now, to get the output from the softmax, we are going to apply this, function of neural networks and softmax. Okay, just remove this comment. We'll keep this. Okay, so this will apply the softmax to the scores across the sequence dimensions. Okay, to get the attention weights. Okay, so that is what is going to happen. The next thing is calculating the context vector. Okay, so calculating this context vector. Okay, so what is going to happen is, and just let me add a comment here. Okay. Okay. Yeah. So this will be much easier for you to understand. So this will basically compute the context vector for the encoded outputs or the encoder outputs using the attention weights. Okay. Now, the next important part is what it is going to return. Okay, we have few functions and what it is going to return. Okay, so the first, yeah, I think anyway I mentioned here this should be enough, but I want to add one particular comment. Okay, so here the output which is okay, that is basically the weighted encoder output. Okay, so that is what here we are going to take. So after that, the second important thing is the attention weights, what it is going to get as an output. Okay, there is one thing. So weights over the encoder steps. Okay, so after that, there is the next important function. What we are defining here is the decoder function. Okay, so we are defining the decoder function. Now, for the decoder function, so basically this decoder function will, this part again you are familiar. Okay, so it's not a new part which you are seeing now. So here the decoder part you are using the Keras model, and then here again we are creating one I would say we are creating again, a default constructor using the vocabulary size, embedding dimensions, units, batch size, as well as the attention mechanism. Okay. Yeah, decoding units. Yeah, DC is nothing but the decoding units. Okay. So, or decoder units, I would say. So the same thing which we are applying here, the same thing only here. And again, the batch size and the decoder units again, and applying the GRU. So everything is the same here, what we are again building. Okay, what we have done for the encoder, we are applying as a decoder as well. Okay, so the same thing, I'm not going to explain again. You'll be able to figure it out. Okay. And after that, we are applying the layers for the vocabulary size. And here you can see the Luong's attention instance as well. Okay. So that is also is there. So mm, okay. So next step, yeah. So next step is we are calling the encoder. So this is also not new. Okay. This is also we have already applied. Okay, so calling the encoder here. Okay, so calling the encoder for both for the X as well as the hidden. So this also step is not new. So after that, we are going with the self-embedding. This is also not new. Okay, so this is also already you guys know. So this is also I'm not explaining again. So after that, the next thing is the batch size. That is also by applying this GRU, you can get the state, okay, output state as well as the state of the, this one. So this is also not new. Then then here you can see something new here. I'll put this comment down. Okay, yeah. So now you are creating a Luong attention, okay, for the context vector. So context vector is nothing but understanding the context. In real-time applications, you can understand. So based on the real-time context, what we are actually going to, how based upon a certain context, the model is going to understand what you require. So for that only, our hard work is going to be on. Okay, by using this context vector as well as the attention mechanism, we are trying to achieve that. Okay, got it now. After that, the next important thing is applying the concat function. So this also you are aware of. Okay, so this will basically concat both the context vector as well as the decoder output. Okay, so which is the target hidden state. Okay, so this is the important aspect of when we are trying to use the concat function. The next important thing here is the dense layer for the final output. So now by doing this, what we are trying to achieve here is we are going to return the output state as well as the attention weights. Okay, so all these are basically returned. Now, to understand in a very simple way, okay, so here I will add one particular comment, okay, because I just limited the comments to a very minimum. Okay, so this is the summary of what we have done. The first important thing is we have implemented the GRU for the sequence to sequence architecture. After that, since we are not just applying the sequence to sequence architecture, we are trying to apply the Luong attention. So we have used the three variants which are there in the Luong's architecture or Luong's attention. Those are dot, general, and the concat function. Okay. So after that, we have used the So already we have seen that okay, we can use the state to predict the next word. So this is the in a simple way to understand what we have exactly done, because this Luong attention is basically based upon the I would say a current state, right? A current hidden state. Okay, so that is very important. Now let us go with one more small example of how this Luong attention is applied into the sequence to sequence model before we wind up for today. Okay. So we'll stop with this Luong attention, because from tomorrow we will see some new things. Okay, because so much of practical part also have been. So there are a few theoretical aspects again where I wanted to explain. So we will go with that for tomorrow's session. Okay. So we have one more important concept, which is the transformers. So how to implement the transformers and all that we will see in one session, because that is again one big. Tomorrow we'll keep as a theoretical, trying to understand a few things again on Gen AI. Day 14, let us go with the transformers concept, and then 15th we'll wind up by implementing, with the one of the important, trying to understand how the role of NVIDIA into the Gen AI. Okay, so like that we will try to plan and we will try to wind it up. Okay, so trying to understand about this Luong attention, the most important thing is, first of all, we have to define the hyperparameters. So hyperparameters are nothing but parameters which are very important. Okay, so in context of in context of building the model. Okay, so in context of building the model, whatever the parameters are extremely important, so that is going to be applied, or that is going to be understood by using the hyperparameters. Okay, so the first important parameters we can see. Okay, the first important parameters what we can see is the vocabulary size, embedding. Sorry. Yeah. So the first thing is basically the vocabulary size, and after that we have embedding dimensions, and then we have the encoder units and the decoder units. Then we have the batch size, and then the sequence length. Okay, and sequence length. Let us not say dummy. Okay, just added a comment like that. But let us say the target sequence is also 5. Okay. Yeah, first one we define the hyperparameters. Now, the second step basically is instantiate the encoder Luong attention and the decoder class. Okay, so for this we are defining the dot product. Okay, we added this for some other thing. Okay, yeah. So here we are using the dot product function. Okay, to implement. We have three dot, general, and concat. Okay, so we are applying the dot product for initiating or instantiating the thing. Now to create this for inputting data. Okay, we are creating one. Yeah, it's actually a dummy data which we are trying to create, which we can implement. Okay, so the first thing is we have given the vocabulary size. Here, whatever we have given is that only. Okay, so just some particular hyperparameters with some data we have given so that we can define them. Okay, so the first thing is the random uniform function we have given for both of them, for the encoder as well as the decoder. Okay, now the next important thing is initiating the hidden state. Okay, so here we are initiating the hidden state here, and then we are applying the forward pass method. Okay, so here for forward pass, we are basically okay. Yeah, so this is very important actually. I just wanted to add here. Okay, I just added this. Okay, I just added this much before actually, not for this session, but for some other session I've added. But to understand in a very simple way, okay, I've just mentioned here also that in the real world scenario, when you see the decoding, that is basically done step by step. Okay, so where the output of the previous step is the input to the current state. Okay, so we simulate a single step of the decoder for demonstration. Okay, because we are seeing just one dummy example. All right. So to understand how this is done, we for this we are going to use a single step. Okay. So we'll use the first token of the dummy decoder input and the encoder's final state. Okay. So after that, we apply the decoder's initial hidden, which is equal. We are making it equal to the encoder state. Okay. Now the next thing is sorry. Yeah. Now what we will do is just give me a minute. Yeah, creating dummy and then applying the forward pass. Yeah. So here I think I have added also. Yeah. So the next step, what we are doing is we are trying to add one step after the other, single token, then the previous hidden step, then the encoder step, and so on. So for that, we are trying to return a few values. Okay. So after applying, okay, I think this should be fine. Okay. Yeah, this should be fine. Okay, this is one step actually. Okay, so we'll take like this. Okay, so this is basically the first token, which is being actually applied. Okay, so this is done using the single decoder variable here. You can see. So single decoder input token, which we are taking here. Okay, after that, we are going with the decoder state. Yeah, just for a minute, I was just a bit confused. Okay, so here we have taken this particular variable and we have used this decoder state here. You can see it here. And then we have already defined this encoder output. Here you can see. Okay, this has gone up. Okay. Yes. So after that, we have applied the decoder state as well. Now, to simplify our approach, since we are just applying as a, just for like a demo for you guys to understand. So for the simplified approach, because actually if you see Luong attention, that coding part will be so much fun. I had a couple of projects on that. It will be very big that it took a day or a couple of days for me to understand the complete structure of the project. So it will be such huge. Okay, so you will not see this much amount of size of coding. Okay, so since it's just a for a small demo, I've taken this small piece for you, for to make you to understand. Okay. Yeah. So next thing is for a more complete approach for the target sequence. These are basically what we are doing is the ending of the hidden sequence will be the starting of the first sequence. So in that way, we have defined in such a way. Okay. So that is what this particular part is basically about. Okay. So after that, we have applied the stacks. Okay. So, one stack is here in this certain scenario is nothing but one after the layer after the other. So for the hidden layers, it will be, framing the sequences in one sequence after the other. Okay. So in that order, it is going to frame the sequence. Okay. So after that, we are going to print the outputs. Okay. Here you can see the output. So the output actually, you'll be seeing the outputs in a similar way. But here we are trying to apply the Bahdanow's sequence, not in the same way, but for Luong, we are applying in a bit of different way because the way this Luong attention actually works. Okay, so this is the output, what you can see. So you can see the encoder's output shape, encoder's shape, and then we have the decoder output, then the decoder state after one step, then the attention waits, and then the attention waits for the sequence step. Okay, the same thing, whatever we have done, I have just mentioned here. Okay, so you can just go through. It is just the steps what I have done. I have mentioned here as a code. Okay, so I just mentioned as a steps. So I just use a print statement and I have just printed like this. Okay, so I have not done anything. It's just the entire thing what we have done. I have printed here. So you can try and apply this Luong attention in that particular way. Okay, so it will be easy for you to understand that what exactly is this Luong attention, which we were speaking about. Okay, anyway, I'll share this also. Okay, so if you have any questions, you can just ask me. So to everyone, I think I have yeah, I have shared Barnow's attention. I will also share this Luong attention. Okay, so I'm going to share. Yeah, now it's going. Okay, so previously I've shared the Barnow's attention, probably an hour ago. Now I'm sharing the Luong attention also. Okay. So you can also try these two. Okay. So try and understand the concepts what I have explained. Okay. So tomorrow let us see a few theoretical aspects on Gen AI. Okay. And then we'll go to the transformers concept. So if you have any doubts, you can please ping me. You can just text me in the chat. I'll just answer your questions. I know it's a bit tough to take in, the bit tough to understand this Bahadano and Luong attention. I can understand that. Okay, but just put your efforts as well to understand that what it is. Okay, use the video to understand as well. Okay, so if you don't have okay, right. If you don't have anything, we can wind up the session. Okay, it's already 9. We'll wind up. Okay, then. Bye bye.